Hello everyone, welcome to Olsen Cafe. Now in this lesson, this is a continuation of the previous one. Yeah, so over here in this lesson, we are going to explore how we can sheet Venn diagrams to illustrate the relationship between sets, in particular the intersection and union of two sets. Yeah, we are also going to discuss the common challenges in understanding how to correctly shape the areas that represent the intersection and unions of the two sets. Yeah, so to begin with, what you will see here is the various example of Venn diagrams that you will see. So this is a three circles Venn diagram. Then this is the one, if you have read the book Ikigai, this is nothing, this will be nothing new. Yeah, so this is a four circle Venn diagram. All right, for us to help out Ikigai is a very good book. I encourage you to get one and to read. So this is another one, another types of Venn diagram. It is actually Venn diagram, so you can see the good user experience. It is a common intersection of all the three areas: the aesthetic, usability, and functionality. Yeah, so we can also use Venn diagrams, all right, to illustrate happiness. So if you want to be happy, right, truly happy, so what you see is, you should be looking out for, must have good health, must have family support, friends support, or even have a positive outlook. So these are the various examples of Venn diagram. So for what we are going so over here in this lesson, we are going to first to talk about the intersection of sets. So what we're going to focus on is only two circles. We are not going to touch on three circles or four circles. It is just on basic on two circles. So what you will see here is this term intersection. So intersection simply means the common element. So what does it represent? All right, it will be this green shaded region here. So this actually represent A intersect B. So the symbol for intersection is like a symbol that look like a letter N. Yeah. So this simply refers to A intersect B. So it simply means A intersect B simply means, right, the elements are in A and in B. Yeah. So that is the first term that we need to be familiar, which is called intersection. Okay, next we look into this term called union. So union, the symbol is look like a letter U. So it's, if we talk about A union B, it simply means the element is either in A or in set B. So if we are looking at the Venn diagram, so if it's either in A or in B, so if we are going to shape to represent, right? So this will be the A union B. So in layman term, we say that, it's all the elements, all right, every elements in either set A or in set B. Yeah, so that this will be A union B. Now, how about this joint set? Earlier on in my previous lesson, I covered this joint set. So in this joint set, if you can remember, it simply means that there is no common element. So basically, how the diagram look like will be, there will be two circles, and the two circles, there is no overlapping area at all. So the notation that we use here, it will be, all right, empty sets or the null set. So in this case, we say that A intersect B, it is actually a null set because there is no common element. Now, beside intersection and union, there is another term that we need to be very familiar with, which is what we call the complement of a set. So what does this term complement of a set refer to? So this complement of the set is simply, right, referring to everything outside of set A. It's called complement of set. Yeah, so the notation here, what you can see is, you can see there's A prime. So this is actually read as, right, the complement of the set is written as A prime. So this will be the symbol A prime. So do take note of this, which we are going to use it very often as well. Okay, so over here, I'm going to give you an example of complement of set. In my previous video, I covered the universal set. Yeah, so say if I have a universal set representing all the real numbers, and I have set R that represent rational numbers, are you able to tell me what is complement of set R? So if you can recall, right, earlier on in my previous lesson, I have a Venn diagram, right, that shows all the various proper subset. So if you take a look at real numbers. So real numbers is the most external circle here. Yeah, so this is our universal set. So rational number, it is actually fall under this range here. So are you able to tell me where is the complement of set R? Yeah, so it is actually fall under, all right. So complement of set R, you know, it's R prime. It is actually the set of all the irrational numbers. So this is an example of a complement of set. So over here, we are going to combine the term, all right, the complement of two sets together with union and intersection. So let's take a look at this example here. So I have set A and B. Now, are you able to identify the region that is shaded in blue right here? So you notice early on we have A and B, the two circles, right? So the two circles, that is means set A and set B here. So the blue region is outside. So that means it's complement of this set. So if you can recall, so this can be actually represented by A union B bracket complement. So that means everything outside of the set A union B. Yeah, so it is quite easy to identify the region if you write down A union B complement. However, in most of the question, right, they will give you this term. So it is good for you to see the relationship, how these two are equal. So basically A union B complement, it is actually the same as A complement intersect B complement. So one way to interpret is, right, you can simply take it as once you remove the bracket, all right, you put the complement in, so you have A complement and B complement. So what you do is the union sign, all right, becomes intersection. Yeah, so if you're able to see this relationship, right, it's going to help you a lot later on. Yeah, so this simply means A union B complement. It means not in A or B or both. All right, and then A complement intersect B complement is simply being not in A and it is not in B. Yeah, but need not to worry so much if you don't understand the term here. Yeah, so what is more important is to recognize, right, the relationship between A union B complement and A complement intersect B complement, and how do you shade it. Yeah, so this is crucial. All right, so now we have seen what is the meaning of intersection, union, and complement. All right, let us move on to see how we can make use of shading or Venn diagram to identify the relationship between two sets. Yeah, so over here I have set A and I have set B. So I have also the region in green. This region in green, it is actually A intersect B. Yeah, are you able to identify the region A intersect B complement, or in other words, A complement union B complement? So again, between these two sets, right, they are actually equal, and if you're able to see the correlation, so quite similar to the earlier example. So what I can see here is, if you take it as you remove the bracket, so you just put the prime in, so you have A prime and B prime. So once you remove the bracket, so the sign from intersection, you will reverse and then you can change it to union. So again, in most question, right, they will actually ask you to shade A complement union B complement, and it is more challenging for you to do that. So if you are able to see this is actually equals to A intersect B complement, I think when it comes to shading, it becomes a lot easier. So are you able to identify the region? So as you can see, A intersect B complement, right? A intersect B is the green region. So complement, that means everything that is outside of the green area. So if you are able to see that, right? So A intersect B complement, so that means everything outside of the green region. So this is how it looks like. So when you actually shade, you should not shade the A intersect B. All right, so all the region that is outside of the intersection, that will give you A intersect B complement. Now, how about this? Are you able to shade A intersect B complement? So let's go through step by step. So I take a look at set A. So set A is simply the yellow region here that I've shaded. So now I want this set A to intersect, all right, B complement. So B complement is simply means everything outside of the set B. Now, so let's recall, intersection means the common elements, the common region. So combining these two, what we are going to have is I'm going to move set A into, all right, the set on the right. So what you will see here is, because we use the term common, right, intersection, so common, that means I'm looking at the region that is overlapping. So when we talk about the region that is overlapping, so blue and yellow, when combined together, this will give us green. Yeah, so this green region will give us the region referring to A intersect B complement. So again, I want to emphasize this intersection means the common elements. So common elements, therefore, we look out for the common region, the overlapping region between A and B complement. Now let's look at the other example now. So the other example, I switch around. I say, let's shade B intersect A complement. So again, let's go through the process. So again, we are talking about intersection. So that means I should be looking out for overlapping region. So I start off with set B. So B intersect A complement. So again, A complement, I'm referring to all the region that is outside of set A. So combining these two, I move set B over to the other set. So again, I'm looking for the common region, right? The overlapping region. So the overlapping region is where my pointer is. Yeah. So again, blue and yellow, I combine. This will give me green. So again, this green region here, right, represent the set for B intersect A complement. Yeah, so in this diagram, this gives you a summary of what I have covered so far. So the region, the yellow region on the left, right, so this will represent A intersect B complement, all right, whereas the blue on the right, this represent A complement intersect B, whereas the one in the center, which is green, this is easier for everybody, right? This simply, right, stands for A intersect B. Right, so now that I have gone through some of the basic shading principle, all right, so over here, let's go through some of the summary, right, summary of all the common region that you get to see. Yeah, so the first one on the left here, right, over here, you can see set A is shaded, so this is quite direct, it's just A. Then the one on the right, you notice is everything outside of A is being shaded, right, including the yellow region. Yeah, so that means everything is outside of A, so therefore it is A complement. Now, how about the next one? So the next one, you notice both set A and set B, these are shaded. So that means I know that all the elements in set A or in set B are shaded. So in this case, it is A union B. How about the last one on the diagram here? The last one, you can see it is opposite to the one on the left, isn't it? So it's everything that is outside of these two circles. So therefore, in this case, this is A union B complement. And can you remember the relationship between A union B complement? So that is the one that you guys need to know. So this is, right, the same as A complement intersect B complement. So just remember, when you remove the bracket, you need to reverse the sign from union to intersection. Okay, let's take a look at the next four examples. So the one on the left here, I think everyone knows this. All right, this is quite straightforward. This is A intersect B. And for the one on the right, you can see it's everything outside of the intersection area. So in this case, all right, I think it is quite easy to identify. It is A intersect B complement. But then again, let's check in with ourselves. Are you able to write the other symbol, all right, the equivalence? So in this case, let's practice, yeah. So once I remove the bracket, so become A complement, B complement, and what I'll do is I will reverse the intersection sign to a union. So therefore, this will give me A complement union B complement. Yeah. Now, how about the next one, the third one on the bottom left? So I see that, you know, the shaded region is outside of B, but it's inside A. So in this case, I hope you get it right. Yes, it is A intersect B complement. Now, how about the last one here? The last one can be challenging for some of you. So let's take a look, yeah. So I have a set A is shaded, and set A is shaded, and also the region that is shaded is outside of B. So outside of B is simply means B complement. So I have B complement. At the same time, I have set A. So that means the element must be outside of B, or it can be also inside of A. So therefore, in this case, if I put this together, right, I will have set A union B complement. So this will give you the set notation for this particular diagram. How about these two examples? Yeah, are you able to write down the set notation? So in these two examples here, we get to see that set B is actually the proper subset of A. Are you able to write it down? Yeah, so over here, the one on the left, I see that the region is outside of B, but is inside of A. So outside of B simply means I will definitely have B complement. Yeah, so is it B complement intersect A, or is it B complement union A? What do you think? Yeah, it should be A intersect B complement, because we are talking about the common element. If I talk about A union B complement, that means I will have to shape the set B as well. Yeah, so over here, this is A intersect B complement. Now, how about the one on the right? In this case, set B is a proper subset of A, and set B is shaded. Yeah, so in this case, all right, it is just simply set B. All right, with this, I have covered some of the common shading or the Venn diagram that you need to know. So what you see on the screen here, it is something that is not in syllabus, but I thought it is interesting for you to go and have a look. Yeah, so shading of Venn diagram is actually not that difficult. All you need is a little bit more of the practice. So what I recommend you to do is go through the video again, pause the video, and then to try to identify the region on your own and see if you're able to write down the set notation. Yeah, so with this, thank you for watching. So if you like my videos, so do remember to subscribe, all right, and like my video. So with this, I see you in the next lesson. Bye.